Okay, class, we're starting with section 3.3, simplest form of a fraction. Section A, writing fractions in simplest form. Fractions that represent the same portion of a whole are called equivalent. Examples, we had 8/12 is equal to 4/6, which is equal to 2/3. That means all of these fractions are equal to each other. Because if you look here, if we divide 8 and 12 by 2, 8 divided by 2 is 4, and 12 divided by 2 is 6. And then we divide 4 and 6 by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. There are many equivalent forms of a fraction. A special form of a fraction is called simplest form. Now, simplest form of a fraction. A fraction is written in simplest form or lowest terms when the numerator and the denominator have no common factors other than 1. Writing a fraction in simplest form. To write a fraction in simplest form, write the prime factorization of the numerator and the denominator, and then divide by all common factors. Use the rules of divisibility to divide out as many forms of 1 as possible. Example, 4 is 6. Both the numerator and denominator is divisible by 2 because they are even numbers. So we can divide the numerator and denominator by 2 using a form of 1. And since both of them are even, we could divide both the numerator and denominator by 2. So we know 2 over 2 is 1. So that's not changing the problem. So 4 divided by 2 is 2, and 6 divided by 2 is 3. We must also incorporate a general rule from section 2.1. Actually, it's section 3.1 for our class. Section 3.1. That any non-zero whole number n divided by itself is 1. Okay, 5 divided by 5 is 1, 17 divided by 17 is 1, 24 divided by 24 is 1, or in general, n divided by n is equal to 1. Also, the following property is also useful in simplifying fractions. We have a times c over b times d, and we could separate this. We could take a over b times c over d, or we could put a over d times c over b, where b and d are non-zero numbers. It will give you the same answer. Okay, now, to find the simplest form of a fraction, we can use some of the methods we learned in section, this would be 3.2. In section 3.2, we would start by finding the prime factorization of the numerator and denominator and simplify. We will use the numbers 18 and 45 that we used on page 51. Okay, so now we take the prime factorization of 18, which we know we could start off with 2 times 9. 2 times 9 is still 18, so we haven't changed the problem, but 2 is prime and 9 is not. But 9 can be broken down to 3 times 3. 3 is prime, and also this 3 is prime. So our prime factorization for 18 is 2 times 3 times 3. Now we go here to 45. We know 5 goes into 45. 5 times 9 is 45. Now 5 is prime. Now we could rewrite 9 as 3 times 3. And our prime factorization, because we know our 3's are prime here, our prime factorization is 2 3's and a 5. Now, we come down here. Now it shows here that 18, you notice we rewrote what the prime factorization of 18 is, which is 2 times 3 times 3. And then 45 was 3 times 3 times 5. Now, if you look here, what they did here with these fractions, they grouped the numerator and denominator that were the same. Now, in class, this is how I showed you to do it. What we did here, we simplify out the 2 sets of 3's we had in common, and we were left with 2/5, which we have here. Now, in this exercise, it shows you here that we could separate the fraction by putting the numerator and denominators that are alike. So we have 1 set of 3's that are alike, 2 sets of 3's that are alike, and what we had left was 2/5. Now we know 3 divided by 3 is 1, which we have here. 3 divided by 3 here is 1. So we have 1 times 1 is 1, times 2/5 is 2/5. And that is our final answer, 2/5. So whether you do it the way how I showed you in class or using this method, you still will end up with 2/5. Now we go here to number 2. We want to find the prime factorization of 30 and 117. Now we look at the number 30. Now remember I told you the numbers that we typically do our divisibility by are 2, 3, 5. And if those does not work, we'll go into 7, 11, and 13. Typically between those 6 numbers, you typically will find about 99% of the numbers that you will be looking for with the prime factorization. Now we look here. Let's start with 5. Does 5 go into 30? And we know it does. So we have 5 times 6. So 5 is prime. And we break 6 down to 2 times 3. 2 is prime and 3 is prime. So our prime factorization is 2 times 3 times 5. Now we go to 117. We know 2 and 5 does not work with 117. But let's try 3. Remember I told you you're supposed to add all of the individual digits, which would be 1 plus 1 plus 7, which would give us 9. So we know 3 goes into 9, so 3 would go into 117. So we had 3 times. Now we can go off to the side here and take 3 into 117. 3 goes in 11 3 times. 11 minus 9 is 2. Bring down your 7. 3 goes into 27 9 times, and you had no remainder. So it'll be 3 times 39 is 117. Now we know 3 is prime and 39 is not, because 3 times 13 is 39. So 3 is prime and 13 is prime. So our prime factorization of 117 is 3 times 3 times 13. Now we will rewrite this fraction. 30, our numerator would be 2 times 3 times 5, and our denominator would be 3 times 3 times 13. Now in class, we simplified out these 3's. We multiplied what was left. 2 times 5 is 10, and then 3 times 13 is 39. So our final answer here is 10 over 39. Now it says note, remember they're using the divisibility rules from pages 51 and 52 will assist in finding the prime factorization of the fractions in order to simplify. Okay, now let's go here to problem number 1. It says 18 and 45. Let's find the prime factorization of 18 and also 45. 18 we know breaks down to 2 times 9. 2 is prime, 9 is not. And 9 breaks down to 3 times 3. And we know both of these 3's are prime. So our prime factorization of 18 is 2 times 3 times 3. So our numerator would be 2 times 3 times 3. Now we do 45. We have 5 times 9. 5 is prime, 9 is not. 9 breaks down to 3 times 3. So we will have 3 times 3 times 5. Now our denominator would be 3 times 3 times 5. Now we simplify this. We have 3's in common here, 2 sets of 3's. So they simplify out, and that leaves us 2/5. Now we have 30 and 117. Now we look here. Now we did that in a previous problem with 30 and 117. Actually, since I simplified it here, we have 30 over 117. We know the prime factorization of 30 is 2, 3, and 5. 2, 3, and 5. And we know the prime factorization of 117 is 3, 3, and 13. These 3 simplify out, and you add 10 over 39, which is basically the same process. Now also, well, I'll write out the prime factorization of 30 and 117. 30 is 2 and 15, and 15 is 3 and 5. Now 117, we know 3 goes into 117. It'll be 3 times 39. 39 breaks down to 3 times 13. Now prime factorization is 3, 3, and 13. And this is 2, 3, and 5, which we did in the previous problems. Now we go down here to example set A. They want us to simplify 15 over 21. Now we've done the prime factorization of 15 before, which was 3 times 5. And we've done the prime factorization of 21, which is 3 times 7. So these three simplify out, and our final answer is 5 sevenths. Now we look here at number 2. Now in previous problem, we did do the prime factorization of 39. We know that's 3 times 13. Now we haven't done 42, so I'll go off here to the bottom here. 42 breaks down to, we could do this, 2 times 21. 2 is prime. Now we already did the prime factorization of 21 here, which is 3 times 7. So we know 3 times 7 is 21. So our prime factorization of 42 is 2, 3, and 7, which we will put here in our denominator. Now these three simplify out, and we will be left with 13 over 14. Now we scroll down here to number 3. We've done the prime factorization of 25, which is 5 times 5, and the prime factorization of 49. Now take a look here. We know 2 doesn't work, 3 doesn't work, and 5 doesn't work. Now I told you to try 7. 7 does go into 49, and it's 7 times 7. And these are prime numbers. They have nothing in common, so your final answer is 25 over 49. Now we go here. We've done the prime factorization of 18. Now we know the prime factorization of 18 is 2 times 3 times 3. So now we're going to do the prime factorization of 54. Now we can have 2 times 27. 2 is prime. 27 breaks down to 3 times 9. 3 is prime. And 9 breaks down to 3 times 3. So we have 2 times 3 times 3 times 3. Now if you notice here, we have a set of 2's and 2 sets of 3's that are in common. Now I told you all before in class, whenever everything simplifies out in your numerator or denominator, that equals 1. You do not leave that blank. And in our denominator, we had 3. So our final answer here is 1/3. Now we come to algebraic fractions. We do the algebraic fractions the same way we just did the other problems. The only difference is this sentence that starts here. When we get to a variable that's taken to an exponent, we expand that variable, and then we simplify. So let's do this first. Let's do the numbers first. 18. We know 18 breaks down to 2 times 3 times 3. And 27, we figured out, breaks down to 3 times 3 times 3. Now we write times the x we have here. Since it's only one x, we write the 1x. But here we have 3 x's. So we multiply 3 x's. Now we simplify everything that is the same. We have 2 sets of 3's that are the same, and we also have 1 set of x's that are the same. So now in our numerator we only have 2. In our denominator we have 3, and we have an x times x, which would give us x squared. So this will be our final answer here. Now we go here. Same thing. Let's do the numbers first. 12. 12 breaks down to 2 times 2 times 3. And your b's, you had 3 b's. Now your denominator, 18, breaks down to 2 times 3 times 3. And we have 2 b's here. Now we simplify out what they have in common. They have 1 set of 2's in common, 1 set of 3's in common, and then we also have 2 sets of b's in common. Now in our numerator we will have 2b. In our denominator we'll be just left with 3. And that's it. Now we come to section C, determining whether 2 fractions are equivalent. If 2 fractions are equivalent, then they must simplify to the same fraction. When trying to determine if fractions are equivalent, we can use the methods we used earlier to simplify. Example, 16 over 40. We do the prime factorization of 16, the prime factorization of 40. And as we did in class, we could simplify out what they have in common. And you notice we have 2/5. So 2/5 and 16/40 are equivalent fractions. And then also with everything else here. Or we could do 10/25. Let's do a comparison. Now we did the prime factorization here. Only thing they have in common are these 5's, and you're left with 2/5. So 16 over 40 is equal to 10 over 25. They are equivalent.